In this video we're going to be looking at the effects of y equals x plus a all squared. I'm going to compare it to the y equals x squared graph like we've done in previous examples, and we're just going to see how these graphs compare with the basic parabolas that we've been looking at so far. So as in previous videos, all I've done is I've started off with our grid to work out our coordinates, and I've just substituted in the values of x into this equation to work out our y values in both cases, and I'm just going to be making the graphs of each of these. Now I've already put in the y equals x squared graph. You notice that I've gone all the way up to 25 here, mainly because we've got a 25 in here as well, just to sort of show you that it doesn't really matter how far we go with this. So we'll start off with the x plus 1 all squared graph, and we see that our turning point at the bottom, we see there's like a symmetrical sort of pattern here. It's at -1, 0, so that's where I'm going to start when I'm drawing this graph up. That's always a logical place to begin, is where your turning point is going to lie. So -1, 0, then we've got 0, 1, and -2, 1. And we can see straight away, if we compare this point here, we've actually moved 1 point to the left, so we'd expect 1 point to the left of each of these as well. And sure enough, we've got -3, 4 and 1, 4. So -3, 4 is one place to the left of the x squared graph, and 1, 4 rather, is there. We've got 2, 9 and 3, 16 all to be put in here as well. So 2, 9, there's 2, and 9 is there. And then 3, 16 will be up here. Obviously we can then mirror it on the other side as well, so we'd have -4, 9 and -5, 16 just there. And without even drawing it, we can see that all that's happened is this graph has moved one place to the left. So let's draw that in very, very quickly. I'm not going to go as far as the 25 here, because in all fairness, we know what's happening with the graph. Again, you guys will be able to make a much neater graph than I can. I'm just going to stop it there, okay? And then in the other one, I mean, we could go as far as that, but our turning point here, we see that our symmetry bit is here at 2, 0. So 2, 0 lies there. Okay, we've then got 1, 1 and 3, 1. So 1, 1 and 3, 1. It's actually on the same point as the y equals x squared curve. But we'll notice that with the y equals x minus 2 graph, that this has moved, this turning point at the bottom has moved 2 places to the right. And similarly, both of these 2 points here, 1, 1 and -1, 1, have moved 2 places to the right. So it should follow, we're expecting, if this is our next term, we're expecting 4, 4 to come up. Well, let's think about that. 4 take away 2 is 2, squared is 4. So 4, 4 would actually work on this. 4, 4 is here, and sure enough we've got 0, 4 as well. 0, 4 being there. -1, 9, -2, 16, -1, 9, and 2, so -2, 16 would be up here. And similarly, we could say that 5 - 2 is 3, squared would give us 9, that would take us up to here. I'm not going to go any further because we've reached the limit of our graph. So make sure you've got your x and y on the axis as well. I'm just going to join them up exactly the same way as we did before. It's just a basic graph, so excuse the sloppiness of my curve. Obviously it would go up to there if it was 6:15. We can see that it has moved 2 places. Each of these has moved 2 places to the right. That's maybe different to how you'd imagine it to begin with. Normally when we look at these kind of graphs, if you said x plus 1 all squared, it would be very tempting to say that the graph is going to move one place to the right, but it doesn't. This moves one place to the left. And this one here, similarly, moves 2 places to the right. Okay? So what we can do then is we can say that in these examples, if A is bigger than 0, the graph moves A places to the left, and if A is less than 0, the graph moves A places to the right. Okay, and that's it. That's all that happens. So the difference between this one here is where the x and the a are both in the brackets together, and then together they are squared. Compared to our previous one, in the previous video we had x squared plus b, these two aren't in brackets. So this one is why it moves up and down, whereas this one here moves left and right. Okay, there will be some examples for you to try. Please go ahead. And what we're going to be doing in the next video is we're going to be combining both the x plus a and the x squared plus b ideas together. Okay, thank you very much.